No matter what business you're in, your organization creates massive amounts of machine data. It's generated by the sensors, applications, servers, network, and mobile devices that power your business. Without Splunk, this machine data is hard to collect and even harder to make sense of. Splunk makes this machine data accessible, usable, and valuable to everyone. To help you understand how Splunk might help your organization, we have built a demonstration showing you how you can use Splunk to monitor, manage, and understand the energy usage of your buildings. This demonstration will also give you a sense of how different roles within your organization might use Splunk to answer different types of questions, all from the same underlying data. Whether you're an executive, operations manager, or engineer, Splunk can help provide the level of detail that you need. Now let's see how it's done. With energy costs spiraling, you're probably well aware of the importance of monitoring energy usage of your buildings and devices. Identifying and troubleshooting problems quickly, ensuring everything is running efficiently, or providing analytics to improve the satisfaction of end users. In this example, there are some key sources of data that we're monitoring from our building to get visibility into these areas. Things like utilities data from each device, power consumption, water consumption, and heating consumption, for example. There are also a range of sensors in the building that we're monitoring, measuring things like temperature, humidity, and light, as well as external utilities pricing data. Now, here you can see a dashboard interface displaying a high-level view of just some of this data. With Splunk's universal machine data platform, we're able to capture this information without the use of special connectors or adapters. We do this in real time so that you have critical information the second it happens. You can see the dashboard panels below moving as I'm talking. If we see a spike in energy usage, we want to know about it immediately so that we can proactively fix any possible problems and ensure maximum cost economy. One of the ways that Splunk is able to do this is because, unlike traditional database technologies, with Splunk there is no need to create predefined schemas. This dramatically reduces implementation costs and provides a fast time to value. Now let's take a quick scenario. I'm an engineer and I'm receiving many complaints from users about our AC units. So let's take a look at this graph below. Here we can see usage for all our AC units along with other devices across our energy network. And we can see immediately that over time that the air conditioning units are one of the biggest consumers of energy of all the devices we have in our network. So let's drill down into this dashboard to get a deeper, more technical look at the circuit breakers in the network. These are metrics and views that are really important to engineers that help them first isolate the problem very quickly, and then also give them the information to fix it quickly by providing the information they need. Without Splunk, each engineer would have to measure circuits individually to get this data and then correlate it together. Splunk can also augment log data with traditional database sources, such as pulling in pricing data. Let's take a look at our state energy pricing view. On this chart, financial executives can see over time, or in real time, prices for locations in which their buildings are based. This can help them understand how much they're looking at spending on energy for the next year, for example, or 2 years. Now this view is made possible by that same machine data we were just looking at, along with Splunk's ability to look up machine data against external sources, like a database or CSV file. In this case, we're monitoring a CSV file produced by the energy companies that shows energy cost by state. Now, let's imagine we have some offices in California. So to begin with, we can drill down into this graph and select California as a state. And over time, it's giving us energy pricing from 1990 all the way up until today. Now let's drill down into this graph a bit further. Now we can use Splunk to give us a prediction of energy costs over time. Now this can be a very useful tool for both operations and financial teams in capacity and financial planning, for example. Now, enriching internal data with external data can be very, very powerful. If we look at it from a national energy point of view, here we can correlate our energy usage to that of our neighbours. Or again, we might want to take a deeper look at how energy companies are making money. Below, we've got a Splunk dashboard showing a map of the industries and revenue by industry for each of these energy companies. And again, this view is made possible by that external lookup, the data we've got coming in from the utilities CSV file. Now, thinking about this for our own use, we could use this map view to show energy usage and costs in our own buildings across the state, the country, or even the world. Just stopping here for a minute, I want to tell you a story about how one Splunk customer uses energy data, specifically fuel usage, to reduce costs for their customers. The Splunk customer in question is New York Air Brake, and they use Splunk to analyze their fuel usage and identify where efficiencies could be made. Things like how drivers are driving the trains. Are they accelerating or braking too heavily? By looking at this data and implementing the changes that came from this data, they're now managing to save their customers over $1 billion in fuel costs. And this is in turn preserving 250 million acres of forestry in the CO2 emissions that would have been emitted as a result. Now, jumping back to the demo, let's take a look at Splunk's pivot feature. From the pivot interface in Splunk, we can also organize the data in a way that makes sense to a business, perhaps non-technical user. From here, we can answer questions that may come up on a day-to-day basis. Now let's take another example. Let's say I'm interested in energy usage in particular rooms. So to do this, I would first choose a data model in Splunk. Once I've selected the data model, I can start to filter and break down this data. So clicking split rows, here we can see the fields that have been extracted by Splunk from the data. Now the structure represented here is applied at search time, so it's extremely resilient to any changes in the underlying machine data that's coming into Splunk. Going back to our example, we wanted to look at rooms. So in this example, I'll take bedrooms, and we will create a label and add it to the table. So Splunk immediately comes back and gives us a table of bedrooms and the count of events seen for each one of our bedrooms ordered by numbers here. Now we want to see energy usage, so let's select the column values attribute and we will change it to kilowatts here. So now we'll get a sum of kilowatts by each bedroom. If I want, I can filter my report by time. And I can also modify the search by changing the column value attributes. So perhaps instead of a sum of kilowatts, I may want to see average kilowatts over time. If we update that, you can see Splunk very quickly goes back and gives us a tabular view of kilowatts by bedroom over all time in this instance. Now, perhaps a table doesn't work as well as a chart. So if I want to view a chart, I simply click on the appropriate chart icon down the left-hand side here. So trying a bar chart first, we can see we've got bedrooms and energy usage, and also a range of options that allow us to further edit and change the criteria in the search that's producing this visualization here. But you can see Splunk ships with a range of visualization options, so if a bar chart doesn't work, perhaps it'd look better as a pie chart. And you can see within a couple of clicks, I've created a nice report that I can easily save as a dashboard panel into those views that we saw earlier. Now, in summary, this simple demonstration has shown that Splunk can be used for robust analysis, improving service levels, and reducing operational costs through quick root cause analysis and proactive monitoring. But don't take my word for it. Go and grab a free copy of Splunk from our website over at splunk.com. Then once you've done that and are up and running, head over to Splunk Answers and ask a question. Along with thousands of other Splunk users, I'm lurking ready to answer them. Happy Splunking!